Hi folks, welcome to Drake's Lounge Australia for 22 June 2024, depending on your time zone. Happy solstice, whether it be summer or winter. I'd like to pay my respects to the traditional and original owners of the land on which we're meeting, and pay respects to those who are trying to understand our place in the universe. So we've got Paul Butler still away overseas. Hope he's enjoying his travels. Welcome to new member Len in Melbourne. We'll say hello to Len shortly. We'll go around the room as is traditional. We'll go around the Australian sector and then pass over to Rich for folks in the US. Good time for those who are looking at the night sky at the moment, of course, down under, because we've got lots of darkness and the sun is below the horizon for quite a bit of the time, so solar interference is minimal, but I guess folks in the US have it the other way around. So, but always interesting at this time of year, depending on where you are. So I might go around my screen here, and actually Len is the first up on my screen. So welcome, Len. Great to have you along, and I'd like to say a few words about your interests and what you've been doing.
Yeah, so thanks, Andrew. So I've got a bit of history with astronomy as an amateur astronomer when I was a kid, and then one of my first jobs was at the Parkes Radio Telescope. I started doing physics, thinking I'd get into astronomy, but realized that that I wasn't perhaps very good at physics, but I ended up engineering, but ended up in radio astronomy anyway as an electrical engineer. I spent a few years there and then moved on into other areas, but maintained an interest in large antennas and control systems for large antennas. So I worked on 100-foot dishes and Australia Telescope and other things. So my career has been mainly electrical engineering and defence research. So I've worked in defence organisations, but I've recently been building a radio telescope. I've got some pictures if you want, but I won't drag this out too long. But I'm building a 2.4 metre dish, and just setting that up now. To do some amateur astronomy on the radio side. Since I'm living in Melbourne, I haven't got good clear skies, so I can't do optical, so I'll do radio.
Yeah, excellent. That's great. So yeah, if you've got some slides to show, that'd be great. But
yeah, I could just flash them up now if you like.
Yeah.
Will it do that? Is that all right?
That's great.
I'll just
whoops.
So you seeing that? So that's sort of the basic configuration. I'm just trying to figure out, do I support my feed with the from the waveguide or from the choke? But anyway, there's a lot of mechanical engineering. So as I say, it starts with a hole in the ground and concrete, lots of trips to Bunnings, but I've built it on a pillar here to get high enough away from the house, and but I couldn't make it too high that it would interfere with the neighbours, so there was a lot of compromise. I've since cut the bamboo, but that's the dish being built on this plinth. And the big mechanical issue is getting these struts to be stable enough. So I'm having to put square hollow section aluminium to be able to hold it properly, to hold the feed properly. And I've had a go at building my own choke feed. I'm using a Sawbird LNA with a Nulec SDR, and so I've tested my antenna, and I'm getting good standing wave, very close to 1, and I've since improved the impedance, low impedance. So that's a quick rundown on what I'm doing, where I'm at. But yeah, lots of mechanical stuff going on at the moment and metalwork.
That's radio astronomy, concrete, metal.
Yeah, that's great, Len. And your dish panels, they're a commercial?
Yeah,
panels?
I just bought a 2.4 meter. It's very heavy. It's like 80 kilos. So I've had to build quite a substantial plinth. I suppose I didn't mind having a solid dish because I might want to do C-band or other bands later. So I kept with the solid dish, even though it's bloody awkward. It's not motorized at the moment, but I figure I'll just do a scanning sort of approach to start with. But I just want to get it sort of started and not spend too much time trying to do mechanical things. But it's hard enough doing the struts and getting that stable and focused.
Yeah, that's great. Yeah. And there's a lot of things in common there with things that are happening in, well, quite right around the country actually here. I remember people working on similar things, so it'll be great to compare notes and of course contribute to the data set that we're hoping to contribute to the folks in the US as well on Southern Hemisphere observation. So yeah. Any
Thank you.
questions for Len and the comments? Yeah, it'll be great to see how that develops, and you've got some contacts here to follow up
that'd
with.
be great. Thank you.
Right. Well, I might pass over to Duncan, who's next on my screen. And hi, Duncan. I hope everything's going well over there. And that pulsar keeps on going.
No, that pulsar keeps on going. So Len, I've gone down a similar track to yours. In building a dedicated non-steerable, well, it is steerable, but it's not steering at the moment. 2.4 meter dish system, but operating where I used to work. Did a lot of work in the frequency domain around 830 megahertz. When seeing 3G has been cleared out where I live in South Australia, it's pretty open sky. I guess 3G has been cleaned out in Melbourne, but I think it'll switch off on the 1st of September all over the country. So there'll be a bit of clear sky. And what I've been doing is I've been using my 2.4 meter, that's actually 2.3 and you minus the rim, to look at the VELA Pulsar, which is something Uni Melb got people interested in pulsars as well as Swinburne University. And I've put a 830 megahertz feed on it, which is what I laughingly call the IKEA flat pack. But basically it's a tongue and slot dual polarization antenna. And I managed to, in the last few months, see a glitch on VELA, and now working through some of the little wrinkles I found in the timing system to measure the time of arrival of VELA pulses. If you can bear with me, I'm just going to share my screen and show you what one of my friends plotted up, because there's 3 of us doing this semi-professionally. I'll just go and share the screen, and where we get to. Oh, can't find it now. Hold on. No, just download it. Oh, downloads a bit. I've temporarily lost it.
If you pop your cursor
Yep.
down to the bottom of the screen, you'll get the bar at the bottom popping up.
Yep. I think I'll come back later and show people, and I can find out where this download went to. Not
Right.
waste everybody's time.
Good. We'll catch up shortly. Roger.
Okay.
Roger's out in the wilds there, it looks like. How are you going, Roger?
Yeah, pretty good. Hopefully you can hear me. Yes.
Yes,
Solstice
all good.
yesterday, of course. So we had a solstice party. Hence you can see me. I'm still there. I camped out in the paddock last night. So the bonfire's still behind me going a bit. Got the sundial in the background. We had about 20 or 30 people. I'm a little bit hungover, but I'm not too bad. So apart from that, I don't really have a lot else to talk about. And I'm hoping that my what do you call it? The link from my mobile phone is going to stay up. It's all a bit tenuous at the moment. But anyway, I say, yeah, welcome from the wilds. Not much else to report. I still got my 2.4 meter dish sitting there. My take on it is that it probably still will be is to try and make it portable. But I just haven't had the time for a little while, but the time will come. So yeah, apart from that, but also I was interested with I only really tuned in when the fellow from Melbourne was talking. I was just a little bit interested on how he's testing his feed horn. He said he's getting a standing wave ratio, how you actually measure a standing wave ratio in a feed horn with basic equipment, I suppose would be the only thing I'm going to need to use.
I bought a fairly cheap DNA for $400. You can buy them, and you just connect it to the horn, and it measures the impedance, the S parameters of the antenna automatically. It's quite good. That just gets the feed. I haven't tested the whole system yet, so there's a long way to go yet. But yeah, getting the feed to be at least good at the frequency that. So it was being on 1450 megahertz, so it was actually quite good and a bit of bandwidth there for the antenna. So yeah, and I can loan it to people if they want to test their feeds. Where are you based?
Okay. In Rylstone, it's north of Bathurst. So I'm north of Bathurst and west of Newcastle on the western side of the Blue Mountains.
Yeah. Okay.
Yeah, those little vector network analyzers are really revolutionized the stuff that amateurs can do. So I bought one myself, and it's great for all sorts of applications in antennas and matching.
Okay,
can you
sounds
guys
good.
put a link
By the
out
way,
to
also
that?
my location. You can see behind me my sundial. The reason I put it there is I'm on the 150 degrees of longitude, so exactly 10 hours ahead of Greenwich Mean Time. So that's about as close as I can set that sundial up on exactly on 150 degrees. So that's 34, 32.4, I think, but yeah, basically on 150. It was a good place for a sundial, I thought.
Excellent.
Roger, can you give a tour of your sundial? I'm not sure how it's built.
Sure. Okay. Yeah, I probably could actually. I'm almost portable. I might take that out. Okay, so it's made out of main piece is a 75 by 120 millimeter, 8 meter long piece of steel, and I chose 8 meters because that's as long as I can fit on my truck. And then the legs are just made out of 75 by 75. Really, the only tricky bit is the two brackets there, so they had to be set up to work for the angles that the legs are angled at, plus the 32.4 target on the end of the gnomon.
Yes, we've got that.
It's just around. Okay, so that produces a shadow with a bright spot in the middle and dark around the outside. It's just so much easier to follow.
Oh, wow.
And then every day at 12 o'clock, I come out here with my GPS and I Okay, so here's my target. So then I bang a peg in the ground every day at 12 o'clock. So I come out here with my GPS and I time it to the second. So that was the solstice. So that was yesterday. That was the same, and pretty well went over the same point yesterday as it did last year's solstice. So it's coming up around here. And of course, it traces that, what do they call it? Animalia or whatever it's called. I can never remember the name of it. So it comes around here and it traces a figure 8. So this is a peg every day at lunchtime until we get to the summer solstice. So that was the summer solstice there. And then it comes back around again, back over here. And we get to this solstice, yesterday's solstice. So really the only main things I've spotted from it so far, you can get things like this section where they cross over back to the solstice is longer than this one. So this is the perihelion here, where it gets closest to the sun, where it's moving faster, and it comes back and it slows down until it gets to the winter solstice. And I think the epihelion or whatever it's called is a little bit out. It's only a couple of days' time, so I'll try and get out here and put a peg in for that one too. So that's basically it. Looks a bit like a giraffe, but you know, it works.
Nice. Excellent. So
Yeah.
great visualization of the motion of the Earth around the sun.
Yeah, that's right. And I intend, well, the other thing that I actually intend doing, and I've got you here, is because of the figure 8, there's actually 2 places in, you know, that can either be like 2 dates of the year when it goes over 12 o'clock. So my concept is to make it so that you can set your watch by it, is what I say. So because there's the 2 points that it can go over in the daytime, I intend putting in what I call the polar seat, which will actually look up the length of the gnomon. And I'm going to start putting, hang on, I'll put this down on here. So then I'm going to start putting pieces out from here to pick up Alpha Centauri. When Alpha Centauri comes out of twilight, it's sort of up around here. So that'll be at a different place at each different time of the year. So that'll then be able to tell you which one of the 2 points to go back to the next day at 12 o'clock and set your watch. It's the concept of it anyway.
Nice.
Anyway, that's down the track a bit. So I also do a little bit of blacksmithing. So I'll probably do that out of wrought iron, I'd say. But I haven't quite got there yet.
Nice one.
Anyway, a big chunk of wood didn't quite catch, but it'll be there for next year. So, okay, there you go. That's what I've been doing.
Thanks, Roger. Thanks for the tour there. Interesting.
No worries.
Nice to set something like that up in your garden.
Yeah,
the sun to follow things. Often miss out on those
and
subtle changes.
That's right. And there is an awful lot you can tell from it. I mean, I haven't quite got the whole bottom of it yet, but yeah, certainly things like, you know, equinoxes and that sort of stuff gives you an east-west line. So yeah, just interesting things. And as I say, the 150 degrees goes through this paddock, so I thought, why not? It's almost an astronomical thing. Yeah.
Okay. Thanks, Richard.
So,
Roger and Duncan, are you able to share your screen now?
So I'm able to share the screen. So here it goes. Well, can you see it says quantized TOAs and VELA timing? So a quick explanation for the panels. The top left panel, figure 1, is I guess is a pseudo signal to noise or pseudo flux density. And that's what VELA's been doing in flux density, in signal to noise when I take the data. Data is taken for 1 hour every day, just to get the SNR up. And the second panel down on the left is the there's a bit of noise on it, and there's actually a cable shift in it as well, a cable length change, which caused a bit of a problem. And then you can see the glitch at about just after 60425. And then we've fitted a line to the data after that, which is a bit noisy. We had quite a bit of solar activity, some really good X-class flares around that time, and it was towards the horizon. So I probably got a bit of that in the side lobes. But you'll see two dots just above where my cursor is. Those two dots are actually real. If you took the RMS of the about the red line, the best fit, they're about 3 or 4 times the RMS. So they actually are real, and that's in the recovery phase after the glitch. So it's not just down, it's actually quite a smooth curve and comes back up. And this was confirmed by Jim Palfreyman at UTAS, who was also tracking at the same time. So that was just a little bit of interest there. You can see delta F on F curve spike here, which shows the response to the change in the frequency. And there's a bias here because of what the pulsar is doing in its spin. And then the panel on the right is something that I'm tracking down in my system at the moment. This is the time of arrivals of the pulse of each day's observation, where I calculate. And you see that it's got a quantized, almost Gaussian distribution. And we're trying to find out why it's quantized, because I would have liked to have seen sort of a random distribution inside the Gaussian. So that's why the little gremlins in the system at the moment. So this all comes off a 2.4 meter dish, fixed at minus 45 degrees declination. Has anybody got any comments?
Scale on that panel on the right there, Duncan. What are the units there? Is that delta F on F?
It's delta F over F, I believe. Okay. So looking at the scatter of the delta F. So it's got some sort of, and it's 10 to the minus 6 is on the right hand side. So it's quite a precise measurement, but I want to find out what's going on inside that distribution, which I suspect is going to be quite a long journey because it's very subtle. And I'm wondering whether it's something electronic. Like my current suspicion is that one PPSs is being measured on the falling edge rather on the rising edge. And sometimes those falling edges have a bit of jitter on them, and that could give rise to this sort of effect. Mind you, that's only a guess at the moment.
Yeah, I was going to say it could be something related to the precision to which you get the time or the edge of your reference time. But you've got some points there that are actually not on those quantized values, so that's interesting. Yeah,
so that's interesting. So at the moment, the last couple of days, I've moved my GPS antenna to a post which is relatively uncluttered by other objects, and so the GPS time for the network time, my local network time's improved. We'll see if that has any effect on the actual measurement of this jitter in the timing. So that's this actually is off of, I think the timing at the moment into the Raspberry Pis is actually derived off a rubidium clock. it's 1 PPS, and the network times off a U-Blocks GPS receiver. So there may be a little bit of a problem there. That's more the reason it's historical, because I didn't have reliable GPS until I moved my sensor, the antenna, to a much more open position.
Right. That U-Blocks, that would be a dual frequency GPS system doing some corrections.
Yeah, it's I can't remember which one. It's one of the timing ones, U-Blocks 8 something, 7, 8. So it's specifically for timing. And what I do there is I take the U-Blocks, it gives me the normal ASCII output plus the 1 PPS, and the second output I actually set for 10 megahertz, but there is a warning here. The output of the 10 megahertz is extremely jittery on my U-Blocks. So I built a synthesizer for 10 megahertz. So, this is a crystal based synthesizer. So that cleans up the jitter in the waveform coming out of the U-Blocks, and phase locks the 10 megahertz crystal, which has really got pretty good Allen bit. Has good short-term Allen variance, but then locks it back to the GPS eventually. And as I've just pulled another clock online, I'll probably be able to now have a look at how they're drifting together.
Yeah, that's quite important to compare against another standard.
Yeah, I think 3 is the magic number.
That's
Right. When a clock starts to go crook, you need to know about it. If you only got one other clock, there's a standoff, and 3 will resolve the issue most times.
Yes. Yep. Definitely my rule of thumb is always compare 3 things together.
Yeah, so that's otherwise that's just goes on day in, day out. I have actually changed I've got another system running with a $30 SDR based on MSI chips, which takes about 8 megahertz, and I'm running that at 4,000 frames a second. So the way you do the observation is you Fourier transform the data into the case it's 8 megahertz, so it comes out at about, and you're doing 2,000 Fourier transform channels, and that comes out at 4 kilohertz, which is actually what you want to sample the pulse pretty well. I was running slightly slower, and I think there's but I hadn't broken Nyquist, so it was all right. But a few more data points doesn't hurt, and then that goes out into some software. It is stored as a file. It's about 3.4 gigs. And then we post-process that through PDMP and a few other little scripts I have access to.
Do you have to take into account dispersion when you're...
Yep. Yeah, the dispersion measure is taken into account. The actual ephemeris of the pulsar is taken into account. So there, there's called DPSR, which is this, which actually de-disperses the pulses, lines them up in effect. And then we have a ephemeris file, which sees what's going on and where the predictions are, and then I run it out in PDMP, which you get a graphical output plus some measured values of period and frequency, and they have errors, but the errors aren't what I think they are, and a signal to noise ratio for the detection. So that's sort of where it's got to. I've just forgotten to say something. Yes, I'm running this all through GNU Radio. So if anybody gets keen about it, happy to share my small script and other scripts. And this is all scheduled. This entire system I don't have to interfere with. it'll just run 24 hours a day until I run out of solid state memory. It just takes 1 hour a day and keeps going. It's adjusted for sidereal time, and it's running through SOFA software under a C program. And you can script other pulsars to go through, but down at 2.4 meters, the only pulsar you're going to see with any quality is the VELA Pulsar. And one of the things if you go after VELA to watch out for is the fact that it's actually sitting in the Gum Nebula, and the Gum Nebula is the remnants of the explosion, and yeah, it raises the system temperature, so you lose a bit of visibility on the pulsar. So just measuring the pulsar flux density by by predicting the pulsar signal to noise without taking into the account that there's a nebula around it which is filling most of the beam of the telescope, plus with the pulsar pulsing away, it does reduce your visibility a bit. So yeah, and these wobbles on the top panel, sort of burble on a bit, but these wobbles in the top panel, they are real. They're not, although I haven't gain stabilized the front end yet, and probably won't in this particular thing. These are actually probably refractive interstellar scintillation. The very fast stuff will have to be that goes up and down, like some of these points here. They are real. That's probably intrinsic scintillation, or what they call diffractive scintillation from the neutron star, because it's a very small point source, and it's also got stuff going around it, so we get a bit of up and down. And then we have refractive interstellar scintillation, where the charged material, the plasma between us and the source, we're moving relative to that. So that's like having a scattering screen or in front of you, like a frosted window. I think my best analogy is when somebody drops a couple of rocks into a swimming pool, or makes you see the caustics on the bottom of the swimming pool where it goes dark and bright, and this is sort of what's going on. And we're sort of moving around the sun, so these angles change, and this stuff is actually self-moving. So yeah, we'll see if there's a repeated pattern in a year or two. So I think that I've burbled on long enough.
Any questions for Duncan, folks? One from me. You mentioned you're writing a manuscript. Are you a bit further along with that now?
A manuscript for what?
For the observation of the event.
Yeah, we're a bit further along. We're going to attempt to publish it in PASA. Basically for amateurs, and so PASA is a publication in Australian Astronomical Society. Yeah, we're going to try and we'll cut off in a month or two after everything's settled down, and we've written most of the paper. We're just missing the abstract. It's all referenced, and when we publish it, I'll make sure I can disassemble it, send it around to people.
Okay.
Go ahead.
Oh, thanks, Duncan. That's really, really good. I might have missed it. What frequency are you using the 2.4 meter dish?
I'm using it at 820 megahertz.
All right.
So I'm taking 8 megahertz of bandwidth at 820 megahertz. This is a hangover from a lot of work I did on a now defunct telescope outside Canberra. And a number of us who worked on that observatory have actually are continuing on to develop bits and pieces that we worked on there. So this is a what we call, well, laughingly call a four-leaf clover, but it's actually a development of what they call a four-square antenna. It's basically four conductive petals that are hooked up in a certain manner with a matching network, which goes down to two LNAs that's on the base plate of the antenna. At the moment, I just can't see a picture of one. But if you send me your email address, I'll fire it off. But these are all PC board antennas. They're designed so that we use FR4 board on the top plate for the actual element, and then a low loss material for the matching, but it's still in 1.6 millimeter low loss PCB. And then that comes to a Skyworks LNA, which has been optimized for 700 to 2.4 gigs for its noise figure. And my estimate is noise figures at 25 Kelvin, but there's a fair caveat on that. But it certainly wasn't the dominant problem noise source in the system. That was caused by other things. And that's all mounts. And the reason why the four-square antenna was chosen is it's the width or the square is of the entire thing is around about 0.3 of the operating wavelength. So it fits nicely on a phased array. And these things were used on a cylindrical paraboloid, where you have a phased array down the middle of the cylindrical paraboloid.
Thank you. That's great. Yep.
Yeah, if you put your email address up, I'll send you a picture or two.
Yeah, thanks. I've just done it.
Thanks very much. Bye.
Yep. Len's put that in the chat there, Duncan. So yeah, great. Thanks. Well, that's really great to see that development, and yes, all those little subtleties. But hope you work through all that, and look forward to seeing the paper. So we might move on. Rob Lucas sends his apologies. He's out this weekend at the New South Wales Astronomical New South Wales Dark Astronomy site for the weekend, but his telescope is doing some drift scans in Sydney, which is great. So look forward to hearing Rob's developments next time. Any other folks from Australia here? I don't see anybody else, but I've got a little bit of an update on my observations, which I'll quickly show you. Heading towards retirement, but not getting much time to do some hardware developments, but I keep my solar and Jupiter observations going. And of course, the sun's been pretty active the last month. We've been waiting, actually. There's been some big sunspots on the sun just the last few days, but not much has come of them. But earlier in the month, there was a good set of bursts. And speaking of caustics, here's an observation at high frequencies, 16 to 24 megahertz, spanning about 4 minutes of time here, showing quite a strong type 2 radio emission, but with some banding in here, which is related to those caustics that that Duncan mentioned, in this case coming from the ionosphere. So we've got scattering in the ionospheric layers, and yes, it's just like being at the bottom of a swimming pool and seeing the refraction occurring from that bright emission. And those are the caustics of the bands that are coming through here. This observation on the right-hand side here, so it's a wider view spanning around about 20 minutes of time, showing that burst in amongst some of the other features. And I'm running also a wider band system covering 50 megahertz, and here's the that particular emission seen by that system. But the interesting thing about this event, I've been looking at the ionospheric cutoff frequency, which is dependent on the ionospheric density as measured by what's called the FOF2 parameter. So that's the critical frequency for vertical propagation through the ionosphere, and also depends on the solar elevation angle. So it's basically FOF2 divided by the sine of the solar elevation. And that would give me a cutoff of 27 megahertz. And I wouldn't expect to see radio emission below 27 megahertz at this particular time of day, but I'm obviously seeing it down here, down to around about 16 or so megahertz, at least on this system, which is a bit more sensitive than the broadband. And some of that's due to the fact that at this time we had also some sporadic E layers, and been following up to try and understand what's actually going on. I've got some ionospheric ray tracing I've been playing around with, and it's just one of those rabbit holes you can go down once you start to see something interesting, finding out why you can see it, given the theory. But the ionosphere is quite an interesting beast, and I'll hopefully track down why I'm seeing some of this emission down below frequencies. The interesting part of that is actually seeing galactic emission at frequencies you might not expect to see it, and that's another interest of mine, is looking at the low frequency sky, in amongst all of the interference that we have now from radio communication and over the horizon radars and the like. So that's just a little bit of an update there. I'll just keep recording these events and collecting a set of them sufficient to actually try and look at the circumstances. So a bit of an update there.
So Andrew, I got a question. On Super SID, I get some angles of the day-night variation. It has a big steep up and down, and since we're doing solstices, is there any indication that you can tell where we are in the orbit around the sun based on your solar observations, radio observations?
Yeah, I guess certainly at the VLF frequencies, where you're seeing the change between the day and the night VLF propagation, that's really quite sensitive to the season. So you do see the change between the fundamental and the secondary waveguide propagation, depending on the time of year. I guess certainly in terms of the higher frequencies, that ionospheric critical frequency does come down during the winter time for me. So I certainly don't see, or it actually rises, I should say, rises to higher frequencies. I don't see emission at the lower frequencies that I do in the summertime, when the sun's higher in the sky. So that's certainly an interesting thing. Another thing which I guess some folks, I think Richard Flagg and others have seen over the years, you'll see sometimes solar radio emission at midnight, which is ducted around the Earth in the Earth ionosphere cavity. And there have been some good examples by some folks involved in SARA over the years, showing solar radio bursts that you wouldn't normally expect to see occurring at your local midnight, and that does also depend on the time of year as well. That's something else to keep a lookout for.
Well, I see. I was able to come up with, using the hydrogen measurements, the location of the Earth around the sun, and actually the location of the Earth around the galaxy. And that's just like when Roger's doing his sundial, where he's actually marking it over around the year, and he can actually figure out where he's at. You can do that with hydrogen, and I think if we could figure out how to do it with the solar, we'll get people to actually watch your telescopes regular basis, plot it, understand what's going on, and it's just a great learning tool to figure out. I mean, to actually be able to trace yourself around the sun. So I just haven't seen it done with solar yet. Super SIDS, you can almost do it because the angles are different on the sunrise, sunset variations. And you can almost do it, but I didn't quite figure it out. I'm just not sure if you can do it with a LOFAR diagram with either what you're doing or what Radio Jupiter does.
Yeah, I'll give that some thought. So yeah, certainly with the SID measurements, yes, and there are some really interesting subtleties there with depending on which ionospheric layers you've got at sunrise, or even I've seen some discussion about the effects of stratospheric ozone influencing the propagation around sunrise, which is quite interesting as well. So yeah, I'll give that some thought. Thanks.
Okay.
I might pass over now to you, Rich, for RDUS
Okay.
folks.
Well, let's get Richard Flagg, our other Radio Jupiter expert in Hawaii.
Well, I'll just pop in for a second. I'm just fascinated with all the great work the fellows in Australia are doing, and some really good science, and it's very impressive. Unfortunately, I don't have anything to add as to what I'm doing here in Honolulu.
Okay, we're all still jealous, so that's okay, Roger or Richard. All right, thank you very much. Don Latham.
Good day. I have really nothing to add except that everything neat always happens in the Southern Hemisphere.
I think there's a follow on to that, but I don't want to know it. Okay, thanks. Tom Jacobs, our stellar treasurer.
Good morning. I'll say that since that's, I know it's morning in Australia right now. Nothing really to contribute. Just wanted to listen to see what you're up to. I am still very much impressed by the fact that you're spotting the glitches in the pulsars, and that you can detect that with reasonably small dishes, 2 meter, 2.5 meter. That to me, that's quite impressive. But so I enjoy listening, and I'll stop at that.
Thanks, Tom. Okay, Andrew, I just got a couple of administrative announcements for SARA. The Eastern Conference is August 4th to 7th. Now that's slightly, it could be 5th to 8th for you guys. If you want to get online, just go to the SARA store and sign up for the online, and you can get that. You'll also get a proceedings with that. So you get the hard copy proceedings, and we'll also post the presentations after the fact online, or excuse me, on the YouTube channel. We've also got a brand new SARA gift shop, and let me go and show you that real quick. The what I'm after really is the what I'm after is you guys coming up with a. Can you see that? It looks like a dish.
Yes.
Okay, and featured products. These are the kind of things my daughter actually designed the logos on these. We've got a number of products that we can. It's pretty straightforward. She gets the logo and she can apply them to the different products these guys got on their on-demand store. And these hats are really nice. The keychain, I had one of those. I got one of these shirts, and different these are SARA socks, mouse pads, shirts. So what I'm looking for, though, is I'm looking for some way we can get a Drake's Lounge Australia logo. And so now, by the way, this is saragifts.org. I'll put that in the chat. So
that's our homework. We had that homework from last time. We must get back and keep sketching.
Yeah. So you guys, so you're the challenge I offer to the Australia group is get an example logo you would like to have. My daughter can tune it up. She can combine different logos, present it to you guys, and then we can, you guys can agree on a nice logo we can put on any one of those items. We can easily apply it, and now you'll be able to have a SARA Australia coffee cup or shirt or whatever. And it's an on-demand store, so it doesn't actually take any effort for us to once we get it applied. It's automatic. We've already verified that it does ship internationally. So we got a number of international orders already, and they all went through. So, okay, that's my plug. Back to you, Andrew. Great session today.
Yeah, thanks. Thanks very much, Rich. Yeah, we'll get together and do our logo there. The next meeting we've got's on the 27th of July. But actually, I've just noticed in the background here, and I'll try and share my screen. Got a nice solar burst happening here at the moment on my system, and hopefully you can see that's my receiver running. There's 16 to 24, getting some solar burst there. That's at 39. It's pretty maxed out at the moment, and we've got down here, that's the 0 to 50 megahertz. I'm copying a bit of interference from something local, which is intermittent, but you can see quite complex emission down here. So finally, we've got something happening from those sunspots on the sun. So we'll keep that running, and might have something to report next month on that. Still going. I'll take care, everybody, and look forward to seeing everybody again next month.
Thank you very much.
Thank you.
Keep well.
Thank you.